going to talk about? Let's talk about what we're talking about. Oh, you know what we should talk about actually is, are you guys, who's going to be here tomorrow? Because or be at Oxnard at OHS at the school physically. Do you guys know who's supposed to be here? Let's see. Because they're not going to let you in if you just show up and you're not, you know what I mean? If you just show up, but it's not your day, they're going to say, see you later, go home. Okay. And then also make sure you bring your ID, or you have your ID, like I said before, on your Student View app. And what else? Micah, your camera. All right. Micah, I'm marking you absent. All right. Let's see. Okay. So, make sure it's your day to show up if you're coming tomorrow. And then my camera's been on and off all day, so I don't know if it's gonna work. When did you send that message? Just now? Can you talk, Micah?
Yes, I can.
Okay, well, talk. I can't read the chats the whole time. Okay, look here. Do you guys see? Am I presenting? I'm not presenting.
No, you're not.
Okay, yes. Now Micah's really, thank you, Micah. That's what I'm talking about. Okay, look here, guys. Let me fix Micah's attendance status. Okay, so let's go with where's my third period class starting here? Tomorrow is Wednesday, so who's going to be there Wednesday? Kimberly, it's your day. Alex Garcia, Alexandria Gutierrez, Catherine Laura, Stephen McNaughton, Laura Punto, Daniel Reyes, Lisbeth Reyes, sorry, Elizabeth, Kenji. I think that's it. So that's that's on my list. You guys have that though. You guys have it on the on your app that shows you what day to go. I'm assuming, right? Bryson, doesn't it show on your app?
Yeah, it shows on the website.
Okay, so it's easy to. Is that hard? Is that hard to do, or does everyone know how to do it? You know what I mean, Bryson? Is it? Not that everyone knows, but was it hard to do, Bryson?
Not really, no.
Okay. Okay, so our topic today is graphing and properties of hyperbolas. Graphing and properties of hyperbolas. All right. So, and then tomorrow we're going to review, Thursday we're going to review, and then we have a test on Friday. I got to get on that. So anyway, graphing and properties of hyperbolas. So what is a hyperbola? Okay, first let's write down the equation of a hyperbola. Okay, actually, let's write the equation of an ellipse. Here's an ellipse. You don't need to write this down. You don't need to write this down because you already have it, but I want to compare. X minus h squared over a squared. Now, a squared can be under the x or the y. A squared is the longest one in the ellipse. Plus y minus k squared all over b squared equals 1. Okay, that's the equation of an ellipse. Now, let's write the equation of a hyperbola and compare and contrast. So let's write the word hyperbola. So you got to write this down. Hyperbola. equation. Okay, you ready? See if you can tell the difference. Now, first hyperbola, x minus h squared over a squared minus y minus k squared over b squared equals 1. There's one equation of a hyperbola, and the other equation is, should have wrote it more to the left, but I'll write it below. Y minus k squared over b squared minus x minus h squared over a squared equals 1. Those are the two different equations for the hyperbola. Notice it is exactly like the ellipse, except you have a subtraction instead of an addition. Notice this one, the x rational expression is positive, and the y rational expression is negative. This one, the y rational expression is positive. The x rational expression is negative. Now here's what a hyperbola looks. Let's separate these. Oh, you know, I should say over here, H and K is the center. Okay, H and K is the center, and A and B are going to make a box. I'll explain what that means in a second. But a box is going to be A and B. Okay, so now what's the difference between the two? Let's say this is the x positive, this is the y positive. Notice x goes left and right. So let me get my ruler out so I can make this real pretty. Hopefully you guys are all writing this out. Okay, if the x is positive, notice the x is positive, then our hyperbola will look something like this. Doot, doot. Doot, doot. That's if the x is positive. And very important to note, some here, this point right here, kind of in the middle of it, is the foci. We'll talk foci. Foci. I've heard it called foci. I've heard it called foci. I'll probably switch around. Foci. They're going to be asking for that point. The foci. So that is the x is positive. Now, if the y is positive, notice x goes left and right. If the y is positive, and I'll get into the graph in it in just a second, it's going to look like this. Whoops, this is right here. Notice it goes up and down. X positive, left and right. Y positive, up and down. And here's the foci right here. And there you go. That's the basics of a hyperbola. Notice, if it's a negative, it's going to be a hyperbola. If, you know, the x and the h and k are the center, The A and B are going to help us make a box with the asymptotes. I'll explain that in just a second. But generally, what you need to know now is that a hyperbola is a minus. The x is positive, it goes left and right. The y is positive, it goes up and down. And the A always goes under the x. It really doesn't really matter as far as graphing goes. And we also need to know that the foci is this spot right here. All right. Are there any questions so far? We don't know how to calculate anything. We don't know how to graph it. I haven't shown you anything yet. But in the end, basically what I'm going to show you is how to graph it and how to find the foci. 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 Okay, I'm going to get rid of this in 10 seconds. 5, 4, 3, 2, 1. All right, let's take a look at our homework assignment. I'm presenting. I had everything opened up, but I had to restart my computer because my camera wasn't working. Lego Batman. Lord Business. Okay, let's go to conic sections. And we're going to do the hyperbolas. We're going to do all of them. Graphing and properties of hyperbolas. All right. So, guys, make sure you open this bad boy. Oh, it didn't. Oh, it doesn't. Oh, there it is. Can I upload the whole thing? There it is. I was looking for it. Okay. So identify the vertices, foci, and direction of opening. Okay. Oh, let's talk about the vertices. The vertices, where do you think they are? Right here. Let's see, what color should I do? Let's do blue. Vertices. That and that are vertices. And then here and here are also the vertices. Vertices. I think you guys, I mean, you probably, if I said, you're probably saying, oh yeah, that makes sense. Hopefully that makes sense. Okay, identify the vertices, foci, and direction of opening. Okay, so well, let's say what we're going to do. First of all, let's graph it. Let's graph it, and then we'll be able to answer all those questions. You have to graph it to figure out all these questions. So let's just graph it. Number 1, x squared over 81 minus, notice the minus, y squared over 4 equals 1. Okay, let's take a look. Looky-hoo. So let's go ahead and draw our graph. I don't know what it's going to be like in the classroom, man. All right, checked out. I've been there a couple of times. They have those big, it's going to be crazy, those air scrubbers. Check them out. Okay, what's the center of my, let's see if we go to the easy. What's the center of my hyperbola? I'll call on someone. What is it? What is it? What is it? Christian Cervantes. What is my center?
X and Y.
It has to be numbers.
Oh, 0.
You need it. What's my X and what's my Y? I need 2 numbers for my center. Christian,
Yeah.
what's my X and what's my Y?
0 and 1.
Remember, the center's H and K, right? So maybe you're a little bit confused. Let's go with, stay with me, Christian. I'm going to get back to you. Danielle Ramirez, help Christian out. What's my center here?
Is it 0 and 0?
Correct. Christian, does that make sense? Because I have no H and K, so it's going to be 0 and 0.
Yeah.
What'd you get 1 from?
From the X. That was my bad. I made a
No, it's okay.
mistake.
I'm just trying to figure out your train of thought, but okay. We'll leave it at that. So there's my center. Now, there's not really a center. If you look at my little drawings, right? What is the center here? The center is kind of like right there. This one center is 0, 0, but it's nothing to do with the graphs. You're saying to yourself, wait a minute, how do I know where to draw these hyperbolas? Well, but before I do the center, I want to ask you something. Is this going to go up and down or left and right? You have 50-50 chance. Estrella, what do you think this hyperbola is going to do? Up and down or left and right?
Up and down?
Wait, I'm sorry. What did you say?
Left to right.
Yes. That's what I thought you said. Now, Estrella, how do I know it's left and right? Just the fact that I pretended I didn't understand what you said. How can we figure this out?
Maybe because the X is first.
That's one way of looking at it, but what I'd rather say is the X is positive. Remember,
Okay.
Estrella, are you with me here? Here, look at, see how my X is positive here? That's
Yeah.
my left and right. And the Y is positive. And generally we write the positive first. So yes, you are kind of right. It's
Okay.
up and down. But it's the positive is, we could write it the other way. You generally don't see it, but yes, the X is positive. Okay, so it's left and right. So that's the first question. Now, notice, okay, so now we have to draw a box. This is my A squared. This is my B squared. So what is my A equal to? What is my A equal to? Okay, that's my question. What's my A equal to? Jackson, what's my A equal to, Jackson?
81
No.
or 9.
Yes, square root 9. So what's my B equal to? Let's go with Javier. What's my B equal to?
2.
2. Boom. Okay, so now notice my A is 9. The A is the left and right. Oh, so it's going to be big. 1. So I go from here. I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's draw here. There's my 9. And over here, I'm going to go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like the ellipse. It tells me how far left and right to go, right? Because it's under the X. Now my B is 2, which means I go up 1, 2. I go down 1, 2. Okay, so do we understand those points? I hope so. And so what we're going to do is we are going to draw a box. Flink, flink, flink. Flink, flink. I won't use my ruler. Flink, 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 flink. Draw a box at those points. Flink, 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 flink. Flink, 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 flink. How did I make that box? How did I make that box, Catherine? Sorry, I'm hitting puberty. Catherine, how did I make that box? How did I make that
With the
box?
A and B point.
Yeah, very good. Now, we're going to make the asymptotes. Do you guys remember what the heck an asymptote is? Kevin, give it to me. Tell me what an asymptote is. I've never taught it to you.
I don't know.
you ever heard of that word before? Asymptote?
No.
Really? Jackson, your camera is off. What is an asymptote, Jackson?
Is it like the curve, like the line segment thing?
No.
Oh.
You've learned it's not have to do with parabolas. Jackson!
Yeah.
I just like this saying your name. Kyle! What is an asymptote?
I'm not sure either.
Are you, come on, man. Laura, help Kyle out. What is an asymptote?
I'm not sure either.
Ah! Nikander, I know you know it. Come on, Nikander. Give me some hope.
I forgot about it.
Ah! Have you heard of it before, though? So you forgot, so you remember. So you've heard the name before. You've heard it. Okay. At least I got that. Olivia.
Yes.
Yes. What'd you have for lunch today?
I didn't have lunch.
Okay. Are you hungry?
No.
I'm hungry. All right. Let's draw the asymptote. Since none of us know what an asymptote is, I'm just going to draw it, and then we'll talk about it after we draw it. Okay. We're going to draw the asymptote is going to go through this point, and that point. Okay. We're going to make a line with these 3 points, the corner, and the center. Okay. This center happens to be the origin. So I'm going to line it up and draw my asymptote like this, dotted. The asymptotes are dotted because it is not our graph. Draw the asymptote. There's my asymptote. There's one asymptote. Let's draw the arrow. And let's draw the other asymptote. We're going to draw from this corner to the center to that corner. I'm going to draw the asymptote. Draw the asymptote. Draw the asymptote. Asymptote, 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 asymptote.
Are we now going to graph at the edges of the asymptote? Like this part sticking out? Is that what we're going to graph?
Yes, it's going to trace it kind of. The asymptote.
Here's the definition of asymptote. A line that continually approaches a given curve but is not meted at any finite distance.
Did you guys hear Google tell you that? Anyway, asymptote. A-S-Y-M. Oh, there you go. A-S-Y-M-P-T-O-T-E. That's how you spell asymptote. Now, as I draw, let's draw. We have everything we need. I think Stephen said it. Tell me if this is what you meant, Stephen. Let's draw our figure. That's asymptote. These are our asymptotes. Now, this is going left and right. So that means the center of the box, you're going to go here. You can do a point. There's your vertice. Okay? Your vertex. All right? Let me do it in blue. Okay. Your vertex is right here. And your asymptote, your hyperbola is going to go. The asymptote's like a border that the line cannot touch. Okay? We did those with exponential functions used asymptotes. But anyway, it will not cross that line, but it'll get as close as possible to it. So you draw as close as possible. And then same thing on this way. And this gives us a trace idea of what our hyperbola should look like. And that's the right hyperbola. And the other one, the vertices is right here. And here's my left hyperbola. And there you go. We just drew a hyperbola. Now, solving for the foci, So, okay, what do we have to figure out here? We need to know the center. I think it was the center one. Let me see the questions again. Actually, I'll keep it here so you guys can finish drawing it. Then I'll flippy, floppy, flippy, floppy, flippy, floppy, flippy, floppy, floppy. Pum 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 pum. Okay, what's it asking? I think it was the foci, the vertices, the direction of opening. So we just need to do the vertices and the foci. Okay, so we got the direction of opening. We say left and right. The vertices. That's pretty straightforward. And the foci. Okay, so the vertices is this point right here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the one vertice is -9, 0. And this one is +9, 0. Boom. There's my vertices. My foci, here's how you figure out the foci. Foci. A squared plus B squared equals C squared. The C squared is going to be our foci. A squared is 81. B squared is 4. 81 plus 4 equals C squared. Is that too fast? 85. And so the C squared, C is equal to the square root of 85, whatever that is. But let's say, I mean, you can put in your calculator, it's somewhere here. So the distance, what this saying is the distance from here to here is the square root of 85. That's what my foci is, foci. So from here to here is the square root of 85. So the foci point is square root of 85, 0, right? Or negative square root of 85, 0. That's all you got to do.
The square root of 85 is 9.21954446.
Okay, yeah, you can put that if you want. But I'm just going to leave it a square root. Very good, Kenji. All right, how do we understand? Are we good? I feel like I should do one more. Are there any questions? So again,
Nope.
All right, nice. Again, we know it's opening left and right because it's an X. We make the box. The X square root of 8 is 9, so go over 9 and go left 9. Square root of 2, 2, and then we got our center 0, 0. Make our box, make our asymptotes, and then draw the hyperbolas, and then boom. All right, let's do the next one. Let's see. Let's get one that's a little more interesting. Let's do number 6 because I have a center.
Wait, are we doing 1 through 13 odd or just every single 1 through 113?
Oh, look at this. Do 1 through 15 odd.
Oh.
1 through 15. We can do 15. Should do 16. Look at, you have the answers there too. Look at that. See? So easy. But I like 6 though, but I'll do 5. Let's do 5. Maybe I'll stop at that. We'll see. Everything's pretty much the same. Okay, let's do number 5. And x plus 2 squared over 169. Square root of 169 is 13 minus y plus 8 squared over 4 equals 1. Okay, so, you know, well, that's opening left and right also, right? So let's graph it. Well, let's see. Our center is -8, -2. There's my center. So it's going to the left a bit. So I'll probably need a little bit of space here. So I'm going to go like this. And then I'll go over here. So I got some space. So my center is -8. So now this one's off center. So what's that going to do to us? 1, 2, 3, 4, 5, 6, 7, 8, -2, 1, 2. There's my center. Okay, is that too fast? Whoa, wait a minute. Time out. What did I do wrong? That's not my center. Why did I do that? Oh my gosh. What's wrong with it? What did I do wrong? Someone correct me. Not -8, 2. What did I do wrong? Is anyone even listening?
It's -2, 8.
Thank you. I got it. It's -2, 8. See, I wish I had a pencil sometimes. -2, 8. So I go -2, -8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. I'm way down there. Okay. All right. So now my A is 13. Ooh, I'm gonna fit all that thing. 13. So let's go over 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew, I fit it. 13 and then 13 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 this way. And then 2 up. 1, 2, 2 down. 1, 2. And let's draw our box. Da, 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 da. Da, 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 da. Bum, 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 bum. Bum, 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 bum. Now draw your asymptotes. Dun, 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 dun. Da, 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 da. Oh, that's a little off. Can you guys see what I got there? So then we're gonna go like this. Bloop, bloop. I can barely fit it. Bloop, bloop. Right here, right in the center. You start right in the center. At the end, right? Center, end is my vertice. Bloop, bloop. Bloop, bloop. Okay. So now, my vertex is this point right here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I got -15. 1, 2, 3, 4, 5, 6, 7, 8. -8. There's one vertice. The other vertice is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Down 1, 2, 3, 4, 5, 6, 7, 8. So 11, -8 is my other vertice. -15, -8. 11, -8. Dink, dink. Foci is a squared plus b squared equals c squared, which is 169 plus 4 equals c squared. Right here. A squared, b squared. 173 equals c squared, so it's a square root of 173. Okay. So it's going to be somewhere here. Now, this is where it gets a little challenging, because the distance from here to here, let's do it in green, is 173. So visually we can see, or square root, from there to there, can you guys see that? Is the square root of 173. So how do we calculate that? Well, it's going to be 173. This coordinate is from here to here. This is 2, right? So from here to here is going to be minus 2 distance. So the foci is square root of 173 minus 2. And then I go down -8. All right? How did I get that? So this is 173, but to get the coordinate, we go from the y-axis over, right? So this isn't 173, it's 173 minus the 2. So that's what that distance is. Or, like what Kenji says, you could do the square root of 173 and minus 2. Whatever. You calculated it, Kenji, you could do that. But this is fine. Now let's do this one. Now this is also square root of 173. But this whole distance from here to here is the square root of 173 plus 2. And then we go down -8. And so that's how you do it. Ugh. That's as hard as it's going to get, though. Are there any questions?
Nope.
All right. I heard one no. I think that's all you need to know, because the graph, the same thing with, so we did 1, 3, 5. So already did, you just have to do 3. And then just graph 7, 9. Oh, I feel like I should do 15. But 15 is like what we did yesterday. So, tell you what, I will let you go. If you want me to do 15, you can stay, and I will do it for you. Do it. Stick around if you want me to do it for you. Bye, Nicander. Nicander's out of here. First one. Nice. Bye, Alexis. Bye, Stephen. Bye, Lily. Bye, Danielle. Bye, Bryson. I'm going to get it started. I'm just going to complete the squares and let you guys graph it. If anyone's still here, I will keep going. If no one's here, I'll just go ahead and stop. But okay, let's take a look at 15. Let's get it started. Identify the asymptotes lengths of the transverse axis. Don't do transverse axis, length of the conjugate axis. Don't do that. Length of the latus rectum and eccentricity. Just identify the asymptotes. Actually, you know what? Just put 15. All I want to do for 15 is put it in graphing form. So is anyone here still? I don't think wait. Is anyone here still? No one's here. No one's here?